So I think we're ready to start. I'm Carolina Zambrano, Environmental Policy Director from the Municipality of Quito, and I'm also part of Provia. I'm very excited as a policymaker to be chairing this session on transformative adaptation and climate risk. This is a really emerging topic. It's a little bit exciting and also a little bit scary for people like me. And I think we have to face it and we have to start thinking really about it. Because most of us here think about adaptation mostly as an ongoing process related to incremental measures, but I think that's not going to make it, especially if we consider what's going on in the international negotiations, etc., and how we're going to be facing a climate of 4 degrees warmer, etc. So we have 4 great speakers today. Mark Howden, Phil Thornton, Jonathan Overpeck, and Cynthia Rosenzweig. They are all going to talk about transformative adaptation, from the risks of abrupt climate change to assessing adaptation options, and transformative adaptation in agricultural systems in Australia and also in cities. But before we start, I have a big announcement. Diana has told me that there's a huge bottle of aspirin in the registration table, so if you partied a lot last night, you can go there. So I'm happy to call the first speaker, Mark Howden from CSIRO Australia. He's going to talk about transformative adaptation in Australia.
Thanks, Carolina, and thanks to the organisers for this opportunity to talk. The first presentation after the conference dinner is always a challenging one, and it's really good to see a whole stack of seriously committed, self-selected people coming to this first session. This morning, I'm just talking about transformative adaptation, the Australian experience so far, and in particular, I want to, recognise my co-authors, particularly Anne-Marie Dowd and Estelle Gaillard, who are here at this meeting and who have posters in this afternoon's session. So some of the material I present this morning will actually be in their presentation at the posters, but also Aisha Fleming and Emma Jacku, who are part of the team. We set this project up about 4.5 years ago as a longitudinal study to understand transformative processes within the Australian agricultural context. A couple of points, though. Firstly, transformation is not new. It may be new in the science dialogue, but it's actually not a new concept. It's been known for a long, long time in the advertising game, and transformation is essentially about associating product use with emotional values to try to change the experience of using that product. So, for example, here's an image from about 100 years ago. It indicates that if you actually drink this beer, you turn into an upright, outstanding citizen and a worthwhile member of the community. If you actually look at the same sort of advertising from that same product these days, if you drink this beer, you turn into a sun-bronzed surfing champion. And so it's not only that there's transformation within the product, but the concept and the use of transformation actually transforms itself. The 2 different images here are quite remarkably different. The other thing you start to understand about transformation is that this use of the word is everywhere, and so it's used in a whole range of different environments and situations. So we have transformational leadership, which is where you sort of try to get staff members to align their self-interest with those of the organisation. We've got transformation in political dialogues, in policy, where you're sort of attempting systems or widespread sweeping change. We've got transformational technologies like the internet, transformational science. This is a tongue-in-cheek version. It's rebranding your old work so you can keep the publication record going. But we've also got transformation in agriculture, and this is not just theory, this is actual reality in Australia. And just so that we're clear about what I'm talking about, this is a diagram that I presented in the last adaptation conference in the Gold Coast, which just looks at different degrees of transformation, of adaptation. So this is actually drawn from data, so it's not completely data-free. And what it just indicates is as climate change increases, Those sort of incremental adaptations to your existing systems, like changing a variety, will have benefit in the early stages of climate change, but that benefit starts to run out as you have increasing climate change. So you get initial benefit and then it plateaus out. The question then, of course, is what is the next level of adaptation that you do? And that's what we call systemic adaptation. That's where you start to change the nature of your system, the components within your system, such as the sort of balance between crop and livestock in those systems. And again, we hypothesise in this case that that will have initial benefit and then it will plateau out. And the third level is where you have transformational adaptation, where you do really major changes, changes in location, changes in situ in your system, so fundamental changes or changes in your supply chain. And as you go up that sort of ramp, you have increasing cost and complexity and risk. And so what we were trying to do in our project was actually understand this process so it actually can reduce some of that complexity, cost and risk. So it's actually less error in trial and error as people go down this sort of adaptation pathway. So that's how I'm using the word transformation, and there's different uses of the word in the literature. And what we've actually found, though, is that logically, because of that increased cost, complexity and risk, is that the transformative adaptation should actually happen well out into the future. But what we're finding in Australia is people are already doing systemic and transformational adaptations, even though we're at the relative start of climate change. So again, that point that transformation is not new. So in Australian context, we have quite well-documented examples of transformation across the systems. And we've got changes from sheep to beef because of a sort of weedy grass in the 1800s. We've got changes in land use as a function of climate, decadal climate variability. Irrigated industries where we brought water into the arid zone and transformed that system in those arid zones. Cropping and heavy soils, dairy industry restructuring, a policy-driven transformation which moved it from the coast to irrigated inland areas. Growing of trees in Western Victoria, a very wet, high production zone. Now it's actually got lots and lots of trees there for pulpwood. And we've got transformative adaptation to climate change on the horizon now. So again, that message, transformation, is not new. We've got lots of examples from which to draw some lessons in the past. One of the things we've done in the team is actually just sort of put together a few ideas. One of them is what we call the transformation action cycle, which is essentially just a plan, do, learn cycle, but it's got a nested element to it, so that the little cycle in the middle is just your incremental change. So it's just that simple learning process to actually improve your existing system. The outside circle is the transformational sort of plan, do, learn cycle. And what we're suggesting is people can go from one to the other as they decide to go into transformational change. But then what we're actually finding is that transformed system actually may become the new norm, and then you just go back into an incremental change cycle with that new system. Or in some cases, people find that it's actually not a good idea, that sort of changed, transformed system, and they actually go back to what they were doing roughly before. So that this is not just simple and linear. There's lots of complexities about this. There's also different viewpoints about transformation. So some commentators actually say that transformation happens as a function of failure and in the face of threat. So migration, forced migration being one example of that. Our experience is quite different, and those people in industries that transform actually get a lot of credit for that change, and they get a lot of profile in the media and in the social groups they work with. So our hypothesis is, rather than being a negative thing, is that transformation is actually a real opportunity that empowers people in the face of uncertainty. So it's one of the hypotheses we're looking to test. So in this project, as we've gone through it, we've actually been able to define some of the characteristics of those people who are incremental adapters versus those who are transformational adapters. And the list of characteristics is just up there. So if we look at those people who are incremental adapters, and we have their tendency to be risk-averse and conservative, they're responding mostly to threat in a reactive way, often to multiple stresses, but it's actually quite efficient because there's small time lags and quite clear links between the changes they make and the results they observe. So it's actually relatively easy to do that adaptive cycle within that. It tends to be very unconflicted, few social barriers and cultural barriers, and there's often existing knowledge to support those changes that they undertake. So in contrast, transformational adaptation was almost the polar opposite. So you tend to get those people who are doing that, are risk-accepting and progressive. They're often driven by opportunity rather than threat. They're very proactive. They're actually interested in what they're doing, but it's actually difficult to measure how successful they are because of those longer lags and difficulties in doing that adaptive management. And there's often cultural barriers and social barriers for these people. So there's not acceptance of what they're doing amongst the broader community. So they're often going it alone, which I'll show in a minute is quite important. And there's often a lack of the knowledge of the new practices in the old place or the old practices in the new place. And so it's not easy in terms of the knowledge available for those people. Excuse. And so one of the things that's really interesting coming out of this is when Anne-Marie's looked at the social support networks of incremental adapters versus those transformation adapters, she finds that those incremental adapters have extremely strong social support networks. So they're really well connected within their community and the people who are doing similar things to what they're doing. But the transformational adapters actually have relatively weak social networks. So they're much, much less connected amongst the community in which they live and which they practice. And this is actually very similar to the work going back to Everett Rogers and co. in 1962, where they actually found that early adopters actually tend to have quite different social networks than those people who are sort of late adopters or mainstream adopters. So it's actually quite interesting that there's actually that parallel between those sort of findings from earlier times. The thing that I think is really new here is that Anne-Marie's also looked at the information networks, and they're the polar opposite for incremental adapters versus transformational adapters. So the incremental adapters have relatively weak information networks, but those transformational adapters have incredibly strong ones and quite strong reciprocity. So they're actually dragging in information from a huge range of different sources to support that decision they're making, that complex and risky decision that they're making, which is pretty rational in many respects. So what we're actually getting is some really big significant differences between the social networks and the knowledge networks of these people, which can actually direct us as scientists and policymakers in terms of how we can help those different groups of people. And so I think that's one of the key sort of messages there, is that we can actually help these people in the context that they're making their decisions. Now, I just want to present a couple of case studies very briefly of some of the things we're doing. So I'll just present the wine one and the peanuts one because we haven't got much time here. But if we actually look at the wine industry in Australia, it's a very large and growing industry, but it's actually very challenged by climate change. Wine quality, wine type, wine grapes are very strongly influenced by climate, and that's been known for a long time. Some companies have actually already taken the step of adjusting to the climate changes they're already seeing and they expect to see in the future. So one example is Brown Brothers, who actually were in Victoria, southeast Victoria, which is in the southeast of Australia here, and they have actually bought up land in Tasmania, which is further south and cooler than their sort of historic area. So they're actually doing this in spite of the fact that we've got a long heritage and a long connection to those places where they've traditionally grown their wine and actually had their vineyards and wine selling places. So there's actually significant sort of resistance to these sort of changes for cultural and commercial reasons. What they've found is that they've actually gone about that and found it's actually really positive for them. So they've actually, particularly driven by senior management, so there was a lot of not necessarily support throughout the organisation, but they actually started to actually think about how to plan for climate change and actually how to invest for that future. And they did this because they actually saw climate was impacting on their business on a day-to-day basis in various ways. And what they've actually found is that choice of actually transformational adaptation, buying land in cooler places, is actually a really good one. So it's actually spread their risk in terms of climate. It's actually given them marketing opportunities and massive media coverage. They simply couldn't have ever bought the media coverage that they got from actually making that change. And actually being able to produce different wines which actually have higher prices. So in Australia, grapes grown in cool areas actually have a really significant price premium compared to grapes grown in hotter environments. So they're actually making not only a transformational change, but it's a really sensible commercial decision which probably will bear increasing fruit over the years, if you excuse the pun. The other example here is the Peanut Company of Australia, major company within the peanut industry in Australia. Their traditional area, which was southeast Queensland, in a historically quite wet subtropical coastal location, they found that was continuously getting drier and drier from decade to decade. They looked further north in Australia and saw that was getting wetter and wetter from decade to decade, and they said, well, maybe we can actually do a transformation change and move up there. And so they bought land up there, started the research needed to actually develop the systems up there, work out their production systems and transport links, etc. And what they've actually found that, in fact, it's actually much harder than they thought. So issues such as high establishment costs for the industry, restrictions in labour availability because of the mining boom in Australia, and the distance, the simple fact that they couldn't actually go up there and monitor what's going on a regular basis. And so they actually have sold those land, the properties that they actually bought up in Northern Australia, and have learned a few lessons about the importance of actually doing really good planning if you're going to make those really big changes. And so it's not. So that's an example of where they went from the incremental cycle of learning in the middle. They went out to the transformational change, and then they went back because they actually found it didn't quite meet their expectations. So it's not all positive. This is actually a story about really well-informed decision making. It's not saying we should just transform because it's a new thing to do. So just to wrap up, I think, is that there's a question about what's the role of science within this domain of activity. And I'd actually say that within transformation, we're actually not in the business of promoting it, because it is a risky proposition, and we actually could put our stakeholders in problematic positions if we actually promote what is actually an unviable or unnecessarily risky proposition. We're also not in this position to actually predict this. So all of those changes are essentially a matter of contingency. They're actually not predictable. They're a function of individuals making particular decisions in response to particular stimuli. We're not in the business of predicting that. I reckon we're actually in the business of supporting those changes, and that's what this project that we're involved is about. It's actually understanding the process so that we can actually support that process and thus support the decisions that people are making. We're not predicting those decisions. And I think some of the risks in terms of actually getting to activist or adversarial, sort of proactive about this, is that there are risks, I think, of normative views on what's desirable in terms of transformation. There's a potential reduction in diversity if people see legitimisation of a very limited range of options. There's flawed assumptions about what actually drives decisions for people, so bounded rationality amongst others. And there's the inability within the science community to actually capture serendipity and contingency in that decision-making process. So there's a whole range of reasons why I don't think we should actually be in the prediction game here, in the way of sort of predicting land use change and that type of thing. What I think we should be is actually just supporting sound decisions by competent decision makers so they can make well-informed change. And so it's actually about whether you should actually be doing incremental change, whether you should be doing systematic change, whether you should be doing transformational change, and what are the consequences of each of those in their particular context. And in doing that, we should really learn strongly from our experience with decision support systems in agriculture historically, where in fact our expectations of those helping decision makers have largely been misplaced, and they've largely failed, simply because they were largely science-driven rather than user-driven. And so we actually don't want to repeat that experience in the transformation arena, because we've already learnt that it's actually not a good expenditure of public monies and not necessarily a good use of our time as researchers. So it's, I think, a message about transformation is not a new concept. It's been done before. We can learn from that. Transformation is risky. We can actually help reduce that risk, but transformation probably will become increasingly important as we go into a changed climate future, and I think we do have a role in supporting that. Thank you.
Thank you, Mark. I think we're going to have all the presentations first and then a panel for the questions. And now we have Phil Thornton from CGIAR, assessing adaptation options at multiple scales in the developing world.
Thank you very much, Carolina. Good morning, everybody. I'm going to talk a little bit about assessing adaptation options at multiple scales in the developing world, and I think how this links in to the transformational adaptation work that Mark has just been talking about. Is perhaps I'm going to talk about maybe it's like a platform of different activities that CCAFS is involved with that tries to deepen our understanding about different types of adaptation in different places. So I'll talk very briefly about CCAFS and what it is. It's a new program, and something about the regional scenario work that we're undertaking, and then something about household and community level modelling, and then this issue of evaluating different kinds of adaptation, and then a few concluding remarks. So CCAFS is a relatively new program. It was formed really through the marriage, or the attempted marriage, of two communities that historically haven't worked very much together in the past. And that's the International Agriculture Research Community, represented by the Consultative Group on International Agriculture Research. And, if you like, the Global Change Community, sort of represented by the Earth System Science Partnership. And because both of those communities have different things that to offer each other in looking at this extremely challenging issues surrounding food security in a changing climate. And the objectives are shown here. So it's really about trying to identify appropriate practices, technologies and policies for agriculture and food systems in the developing world, but also trying to support the inclusion of agriculture issues in climate change policies, and conversely, trying to get climate issues better integrated into agricultural policies at a range of different levels. And so again, very briefly, what we're looking for here is, this is what we're after: adapted agricultural and natural resource management and food systems. And these are the sort of our overarching outcomes that we're interested in. So improved food security, improved livelihoods, improved environmental benefits, and then recognizing that, of course, many of these things will not always be operating in the same direction, and so there may be trade-offs, but sometimes there may be synergies. So how can we identify those? And then there are four basic programs or themes of research that the program is divided into. One of the things that we're undertaking is a set of regional scenarios and visioning exercises in the initial three target regions for CCAFS, which are East Africa, West Africa, and South Asia. And here we're trying to explore sort of the interacting socioeconomic and uncertainties regarding future food systems, and doing this with a wide range of regional policymakers and private sector people and civil society, media and researchers. And so this is involving a mixture of both qualitative, so this is getting regional and local stakeholders to write narratives about how the future may look in these particular regions. And then we're also attempting to quantify these using different types of models. For East Africa, this is we have scenarios with four quadrants. So for those of you who are familiar with the Millennium Ecosystem Assessment, for example, this is rather similar, but here we're talking about sort of key uncertainties in terms of how East Africa may develop in the future, and then regional stakeholders, this is their input here. So regional integration, so will East Africa as a region, will it really develop as something sort of cohesive, as a real force in the global economy, or will it sort of carry on as a rather fragmented status quo? And then on the other axis we have sort of reactive governance to issues related to development and food security and the environment, or is it proactive? And so in these four quadrants we have very different types of plausible futures, that they're all plausible. And again, this is not being normative. We're not saying that one is any more desirable than the other, but of course they have very different implications for food security at different levels. And this is, so I should go back, these have been given rather nice names. And of course, since it's East Africa, these are very much to do with wildlife. So these are the cartoons done by a local artist, and actually they're very nice because they capture, I mean, they're cartoons, but they capture some very nice issues surrounding some of the sort of the key elements of the different scenarios. And I quite like the sleeping lions. So this is a very fragmented East Africa, very reactive. So the lions are just sleeping, and then the vultures come in. They may be internal vultures or external vultures, and they're making off with the loot and the natural resources. And so they're caricatures, but they have nice elements that describe some of the differences between the different scenarios. As I mentioned, we're trying to quantify these using a couple of different types of models. We're using a couple of partial equilibrium models, one from IFPRI, the Food Policy Research Institute, which is based in Washington, and GlobeIron, which is based from EASA, just outside Vienna. So the idea here is if we had more time and more resources, we'd take more of a sort of an ensemble approach to using different partial equilibrium models, because basically they're all somewhat different and they have different strengths and weaknesses. But the idea is to try to provide them with sort of a cohesive set of input data and then look at what some of the outputs might be. So just a very quick example would be looking at cassava in two of these sort of the different worlds. So the industrial ant scenarios where East Africa is moving towards really good regional integration, and state and non-state actors are being very proactive. And you'll see in a minute, the next graph shows actually what happens to cassava. Production costs decrease substantially and yields increase by 30%. And cassava, of course, is one of the few crops that's likely, production's likely to increase as temperatures increase, and it has excellent drought resistance. And so under the ant scenario, if you like, you can think of it as a climate smart crop. And compared with if you're looking at this is the sleeping lion scenario, where there's low demand and cassava functions very much as it does these days, which is a sort of a food security crop. And again, this is just, the details don't matter, but this is comparing the Globium and the impact models in terms of what the predictions are for crop demand from sort of current conditions to the 2030s. And again, the only point really to note here is that demand increases radically depending on the scenario, with considerable impacts on cassava prices. And so, of course, then that's fine, but then how does that actually translate into sort of impacts or possible impacts on the ground in terms of households and communities? And this is actually just a sort of a stylized sort of landscape, but it's very typical of sort of many of the complexities of many of the smallholder farming systems in sub-Saharan Africa, for example. And really what we need is to gain more understanding of how households and communities operate, and really is what's really driving their decision making. And to do this, we're developing quite a lot of data collection for some of the CCAF sites to enable us to actually do some of this household modelling. So we have a data collection protocol, and the idea here is to do sort of stepwise modelling. So the broad context for the household modelling or the community modelling is provided by the regional scenarios, and then really what we're trying to focus on is what are the key outcomes of different adaptation options under these different plausible worlds. Because the fact is that many times, even if we have, say, social benefits at a regional or national level, those won't always translate into benefits, say, for producers, for smallholder producers. And so then trying to identify which are the, if you like, the win-win options. We're using a sort of a range of different types of models, and there's some development work on household modelling that we think is needed, and so CCAFS is trying to promote a small community of practice to do this kind of work. Mark showed this, or a very similar diagram to this in his talk, and really just trying to think about sort of what are the types of adaptation that this kind of sort of platform, this sort of set of tools could help us to look at. And so again, he talked about moving from sort of incremental up to the more transformative changes as the effects of climate change really start to bite. And we've, in CCAFS and of course with many other programs, we've been looking at sort of trying to understand also as part of this, sort of how have communities changed over sort of recent times. And of course, I think a graph like this shows that households and farming systems are already extremely dynamic. and they're already adapting to all kinds of different drivers. And so this is 12 sites in East Africa, and they're arranged from low or relatively low rainfall up to relatively higher rainfall. And this is the history of cropping in years. And you can see at the very dry site in Samburu, they're still not cropping, although in Baringo, cropping has sort of been taken on board as a livelihood option only over the last 20 years or so. And then if you start to think about, well, what are the kinds of adaptation or adaptation in the future that households and communities may engage in? And this is, again, from the same study. We're just relating here rainfall on the x-axis. On the left hand, we're looking at the months of food shortage in these households. And you can see that there's some relationship between annual mean rainfall and food shortage, as you would expect. And similarly, also for the number of activities that the household is actually engaged in. And of course, so the issue is, as annual mean rainfall changes in the coming decades, then what's going to happen to households? Are they going to be pushed further to the left in these diagrams? And really the question is, how far can adaptation really go in such systems before you then have to start thinking about, will other livelihood strategies be needed under particular scenarios of how East Africa may look to enable people to enhance or maintain their food security. And so this just sort of tries to summarize what we're doing in CCAFs. The entry point in the regions is really through these regional scenarios, through this sort of very participatory approach to trying to develop these scenarios, and then modeling these up to the global scale, but then with sort of richness at the regional scale, but then starting to look at, okay, what do these scenarios actually mean for households and communities in particular places? And I think the point here is what we're ideally trying to find would be options, technologies, policies that are really robust under several of the different plausible futures. And of course, we don't know how the future's going to turn out. But if we can identify options that may operate beneficially under a range of different scenarios of the future, then those are the kinds of things that perhaps would be worth looking at in more detail. And then, of course, the idea of iteration, we may need to iterate between these various levels to really identify those options that are likely to be genuinely beneficial. So just a couple of concluding remarks. As I mentioned, we're working with developing regional scenarios for the three initial target regions of the CCAFs program, and those should be essentially complete by the end of this year. And for the East Africa work, which itself is nearly complete, the next couple of months there'll be a couple of workshops with policymakers where we'll be doing some visioning work, and there are also some other programs in East Africa that are interested in using the same scenarios, but perhaps for very different purposes. And that's obviously a very nice thing. Since we've gone through the process of developing these things, they may as well be used and utilized. And as the CCAFs program is going global, sort of during the rest of this year, and so there'll be two added target regions in Southeast Asia and Latin America. Then we'll also be undertaking scenarios work in those two regions. The household modelling work as a sort of a component of this, this is being set up in some of the selected CCAF sites this year and next. And just to finish off, there's sort of four things that I think we've identified as being important. And one is this idea of you really have to link different levels to be able to look at sort of how different adaptation options may actually function. And we really need to do this. So again, as I mentioned just before, so what are the robust options that may offer benefits at different levels under different scenarios of the future? And also, what are the limits to adaptation, and how or when do particular stressors become so great as that local communities may have to think about transformative changes? Another important thing is, this is an extremely crowded field. There is so much going on, and it's the importance of linking to other ongoing efforts. And there are several I've listed here. And there's a lot of work going on in the global integrated assessment modeling community. And so then trying to link with that, with AgMIP, which Cynthia has talked about. So agricultural model into comparison and improvement. And there are many global data initiatives. And so sort of trying to make the best use of what's already going on. And that's also linked really to this next point. So the importance of adding value rather than, well, muddying the waters may be a little extreme, but sort of, I mean, this relates, I think, to model, to data sets, to methods, to frameworks. There's an enormous amount of these that have been developed. So can we find, to really help ourselves, can we find what will fit perhaps with just a small amount of tweaking for our particular situations, rather than going through a sort of a redevelopment process. And then finally, the importance of building capacity in the target regions in modelling scenario work and decision support. And so one of the things that CCAFS is very keen on is to develop sort of local teams that are capable of are willing and able to sort of move forward in some of these key areas that can really help in the future. Thanks very much.
Thank you very much, Phil, for the presentation. Now we welcome Jonathan Overpeck from the Institute of Environment of University of Arizona.
Thanks very much. And so I'm a token physical scientist. Thought we would change things around a little. And thank you. Make sure I understand how this works. My goal here is to talk about the kind of change we're going to be adapting to, as opposed to the science of adaptation and the practices of adaptation. And what I want to do is I was assigned to talk about abrupt climate change, and I do a lot of research on abrupt climate change. And what I want to do, instead of just giving you an overview, and for those of you who were up late last night putting you back to sleep, what I want to do is share some new results on Megadrought. And I want to sandwich that between the sort of the state-of-the-art on sea level very quickly, where we stand on that, so you understand where the physical science community is going on sea level. I do a lot of research on sea level and try and follow that carefully. And at the very end, say something about transformative landscapes around the world, and building on something that Steve Jackson said earlier in this meeting. But first, I want to have a preamble, and that is that only trust your models so far, particularly with respect to abrupt climate change. So one of the, don't trust your models, the cool thing is most of our, I work with climate models all the time, and we're kind of quiet about some of the, what's under the hood. And one of the big name climate modelers, Paul Valdez, wrote this paper recently in Nature Geoscience, and he just sort of said what we all knew, which is state-of-the-art climate models are largely untested against occurrences of abrupt climate change. So this is one area where the models are not well tested, and it would be a huge leap of faith to assume that simulation of the coming centuries with these models would provide reliable warning of sudden catastrophic events. So what I want to show you today is some evidence that, at least with respect to sea level, megadrought, and transformation of landscapes, that we really probably should be a lot more concerned and worried and thinking about than these changes than the models lead you to believe. Really quickly, the sea level rise thing. The big problem for all of you who are not physical scientists is that we do not yet have an understanding of the the physical dynamics of ice sheets. The ice sheets are what's going to give us the big sea level rise of the future if we're not careful. And yet we have no models that can simulate those. And yet the paleo-environmental record indicates that we can get multiple meters of sea level rise with just a little bit of warming. And so for example, 6 meters of sea level rise, the areas shown in red show you that are flooded by 6 meters. This is the kind of sea level rise that's happened in recent Earth history in response to small warming of the Earth, both in the high northern and southern latitudes. And closer to home, Florida becomes much smaller with 6 meters of sea level rise. Okay, so what is the consensus? You know, in the fourth assessment of the IPCC, I was involved heavily in that in writing what we ended up saying about sea level, which I still feel to this day was terribly misleading because it didn't reveal what we really, the full range of what we know. I think this is getting better articulated now. There are a lot more papers, and it's becoming clear that the consensus is that we can get a meter or more, perhaps up to 2 meters. Yesterday I spent time with people from the U.S. Military here at this meeting, and they're planning up to 2 meters of sea level by the end of this century. And that's what the U.S. National Climate Assessment is going to say is the low probability but possible change by the end of the century. So a meter, though, is becoming much more an accepted mid-range likely scenario. But the other thing you really need to remember is that we're going to probably cross the threshold sometime in the century beyond which we're committed to much more sea level rise. In other words, the ice sheets may only be able to go and lose mass at a rate equivalent of a meter per century, but it'll be warm enough for those ice sheets to be a negative mass balance for centuries to come. And the paleo record confirms that this means we could get 4 to 8 meters. We could be committed to that by warming probably before mid-century. Okay. Moving on to drought, I'm going to spend more time on drought because this is very current research and it really has, it's in contrast to the sea level thing, which is coastal. This is a lot of the land area where we all live. And I want to dig into the Colorado River Basin. That's the water you're drinking here. But it's also because it's our local problem, but it provides a great example, I think, for how we can use combined models and paleoenvironmental information to get better assessments of what's going to happen in the future than if we just use the models alone. And I'm going to try and draw this out then and show you what the global implications are as well. But so bear with me if you don't like the Colorado River Basin example. It's very important to us. The red dot here shows where we are now in Tucson, but the Colorado River Basin is really 7 states in Mexico share this water, and some of the largest cities in the United States, certainly the fastest growing region of the United States, is in this part of the country. And so this river is very important to us. It also gives us a substantial portion of our agricultural production, and a lot of our native nations are concentrated in this region, sharing the water with these 7 states and Mexico. Brad Udall, Brad's here as well. He's an expert on the Colorado River Basin, not just the science, but the policy and decision-making associated with it. We wrote a paper, a really short paper, trying to summarize this in Science recently. And what I want to do is go into more depth now than we were able to do at that time, talking about what's the real crisis on the Colorado that we're likely to have to deal with. All right. The first thing you have to know is, and I apologize for these wonderful units, but we use million acre feet when we're talking about Colorado River water. Okay. Don't worry about it. The main thing is they're simple numbers, small numbers, so it's easy. But we basically, the law of the river was started in the 20th century, the 1920s, dividing up the water among those states in Mexico, and we essentially divided up our forefathers 16.5 million acre feet, the law of the river. Then along came these pesky tree ring scientists from the University of Arizona, and the classic, most recently published and cited study is Dave Miko and colleagues. He's a colleague here at the University of Arizona. Had a tree ring reconstruction going back not just to the 1920s, but all the way back, 1,300 years, 1,200 years using tree rings. And one of the interesting things about this was that the long-term mean of the river flow turns out to be closer to 14.5 million acre feet rather than the 16.5 million acre feet that are allocated. So all of a sudden we know that we're over-allocated by 15 to 20%. The other thing, as you can see on this, is that the 1920s, when they did the allocation, turned out to be one of the very wettest periods in the Colorado River history. And that's just one of those little ironies that we like to talk about here in the Southwest. So we're already over-allocated. But meanwhile, we've had some really clever grad students, Greg Peterson and Toby Alt, recently got their PhDs here. And what they did is they said, wait a minute, I'm not sure we trust those earlier reconstructions. And of course, their mentor, Julie Cole, myself, but also Dave Miko, the guy, along with Connie Woodhouse, who have been doing most of this work, came up with a new, more reconstruction using more data and more, I think, sophisticated methodology. And they found that the long-term mean, instead of being 14.5 million acre-feet or 14.7, is really closer to 12.8 million acre-feet. So this is about to be submitted, and I think it will be published in a pretty high-profile place. Huge implications, because even before climate change, we're getting into a nasty situation, it appears. Okay, but look at this record, because not only is there the mean flow, there are also these droughts, okay? And the topic of my presentation today is on abrupt climate change, and one of the things that I think is really important for us to understand are megadroughts, meaning decadal droughts, droughts that are bigger than anything we've seen, unless you happen to be in the Sahel. That was a megadrought, but and you'll see in a minute that was a very short megadrought for the Sahel. But here we have never seen a drought longer than the one we're in now, which has gone on for about 12 years, unless you go to the paleoenvironmental record, and then you start seeing these droughts that lasted 25 years, 30 years, and if you go back before this record, we just published a paper, one lasting 50 years, with only 1 year of normal flow. Okay, but the interesting thing in the new reconstruction then is that the flow during these megadroughts isn't anywhere near what's allocated. It's only 10 million acre-feet. Okay, so when you get a megadrought, absent climate change, you have a major reduction in the amount of water that's available. If you add in climate change, which now the best estimates, papers that are in press, suggest 20% reduction in the mean flow by 2050, meaning this is what we're going to get, right? If you add the megadroughts on top of that, you end up with a number that gets you down in the 8 million acre-feet range. In other words, half the water that's allocated. So this is pretty much what we're going to have to adapt to in the Southwest. This will require transformative adaptation, no doubt. It is our job to try and support finding solutions to this. Okay, but why would you trust this new reconstruction over the old classic one? Dave Miko did both. You'd sort of think that he feels more comfortable with this new reconstruction. But Toby Alt, one of these really bright grad students who's now up at NCAR, said, well, look at this. If you look at the old reconstruction, the classic one in gray, and the new reconstruction, most likely data points here, the most likely reconstruction in black, they're different, right? You have much drier megadroughts, you have a lower mean in this new reconstruction. But another way of looking at paleoenvironmental or climate variability is, instead of looking at it in the time domain versus time, look at it in the frequency domain. So and what you discover, okay, is this is an axis, and I know this is pretty physical, sciencey, but this is nothing more than variance on this scale. So think of it as variability. And this is frequency. So we go from high frequency to lower frequency. This is 1 cycle per 100 years. That's the inverse of periods. So this is going to longer and longer time scales this way. And it appears in the original reconstruction in gray here that the variance gets greater and greater as you go to longer time scales. And then when you get to about 1 cycle per 100 years, it just drops off. Just like, and it says that the climate system has the scaling of variance to lower frequencies, more and more variance, and then don't worry about century scale variability. Okay, paleoclimate scientists like Toby, well-trained here at the University of Arizona, but he said, well, that's crazy. And so that's when he took the new reconstruction that Greg headed up, and he plotted that up in the same way, and variance scales linearly out to these lower frequencies. Okay, that makes more sense to a climate scientist. And that the methodologies being used in the tree ring work actually removed the low-frequency climate information when they removed the biological bias they thought would be in the tree as it grows, the trees as they grow bigger. Okay, why would you trust that? Toby also did a neat thing, is he said, well, let's test that by looking at non-tree ring proxies. And he has a number of other types of proxies that are lower resolution from lakes and cave formations. So he can actually go beyond the tree ring based new reconstruction here in red, and he finds that the scaling is linear, more and more variance, more and more variability in the climate system as you go to longer and longer time scales. That means as you go to longer and longer time scales, you should get bigger and bigger mega drought. Okay? Not only do you see that in our part of the world. You also see it in Africa. This is sub-Saharan Africa, northern Ghana, where we have another paleoclimate record that my student Tim Shanahan produced and published in Science a couple years ago. It shows the same thing. Okay, this is the instrumental record, which looks pretty like it's scaling to more and more variance at lower frequencies, but the paleo record says it continues on now out to millennial time scales. And we've done this recently. Sarah White, who hopefully is here, has done this in the Amazon as well. So the more and more we are looking at these records, we're finding that variance of hydroclimate variation scales more or less linearly out to these longer frequencies. And the implication is much greater mega drought risk. Just like I showed you in the example for Colorado with the reconstruction, everywhere around the world, if you take the climate models, whether they're the AR4 IPCC models, or we're now doing this with the AR5 models, they also underestimate this low frequency variation. The models do. But you can correct that bias using the paleoenvironmental information and the fact that there seems to be this linear scaling. And this is the mega drought risk. In other words, a drought that lasts decades occurring in the 21st century, this century, okay? Our part of the world, 1 chance in 3 to 1 chance in 2, okay, that we'll get a mega drought. That's not surprising looking at how frequently they occurred in the past. You see the same thing in parts of Australia, fairly substantial risk of megadrought. Look at this, okay, huge in the Mediterranean region. The record, I'll show you in a minute, that Tim Shanahan worked on was in sub-Saharan Africa, also suggests very large risk, but it's lower than up here, okay? Also, interestingly enough, also the Amazon. So it's not just arid parts of the world. Now what I'm showing you is the same map, but what I've done is I've superimposed where we have paleoenvironmental information around the world that actually tells you how long the droughts have been in the last 2,000 years. In our part of the world, the longest drought we've seen is 51 years, okay, with 1 year above normal. Tim Shanahan's work here in Ghana suggests in that part of the world we get droughts that are much longer than the classic Sahel drought. 100-year-long droughts, okay, have occurred in the last 2,000 years. Those are the scale of droughts that could occur at any time because we don't have a physical understanding of why they occur. They could be a climate surprise. When we talk about climate surprises, this is what we're talking about as a physical scientist. We also, I mentioned Sarah, she got married, so she's now Sarah Leroy. She's found droughts in the Amazon. You know, remember we've had the drought of the century in 2005 and in 2010. Well, she's found over the last 1,000 years there have been droughts that are 10 to 15 years long, okay? So the Amazon has had longer droughts, has persevered through longer droughts, but these are what we truly have to worry about in terms of adaptation. I'm going on sabbatical to Australia. I'm fascinated about learning what the paleo record tells us there, okay? Now, my last part of my talk is on this transformative landscapes, okay? Not adaptation, but landscapes. And I want to make the case that here in the western United States, we're seeing, just today, I don't know if anyone saw it in the news, the new largest wildfire ever in New Mexico, okay? We just broke the record that was set last year, which broke a record that was set just a couple of years ago, okay? The western United States is burning up, and those areas that are not burning up, the forests, are being affected by, I see it, okay, I'm almost done, are being affected by insect pests, okay? And Craig Allen and colleagues surveyed around the world, and you can see these little dots, this paper, there's the reference, are seeing these changes, these diebacks around the world, and also big upticks in wildfire. And what I was joking with him when we talked about this is maybe what we're seeing is the tip of the tipping point. And what I meant was that if you go back to the last time we had glaciers on Earth, the last glacial maximum, the Earth was cooler than today by about the same amount that it's going to be warmer in the future. So if we look at vegetation change over that period, that's 20,000 years, it's going to be forced by this comparable climate change warming that's going to occur in the next 100 years. And Steve Jackson, if you didn't go to our session on paleo earlier this week, he made this statement. He said, all regions on Earth saw significant overturn in vegetation composition since 21,000 years ago. So the implication of this is that you should all be thinking of your vegetation, wherever you are on the Earth, is likely not to be the same in the future. Okay? It's going to be different. Thank you.
Thank you, Jonathan. And now we move to the last speaker of the plenary, is Cynthia Rosenzweig from the NASA Goddard Institute for Space Studies.
Thank you, Carolina. We're now going to turn from some of the landscapes that Jonathan was just speaking about to the populated areas of the Earth. And the question that was posed to me was, can cities adapt to rapid climate change? So I'm going to be sharing some of the ideas that we've been discussing in the Urban Climate Change Research Network, UCCRN, which is a group of about 300 scholars and experts who work on all aspects of climate change and cities. And the themes are transformation, one of the themes of the plenary, climate risks, and, of course, adaptation. So the first transformation that I want to talk about is the transformation of perception of cities as key actors in climate change. When you look back at the history of the scholarship, it's quite astonishing how long cities were ignored in global climate change research. And this was despite uniquely relevant factors, such as multiple environmental stresses, the majority of the global population, hubs of economic activity, and also that they are frequently located, really virtually always located on coasts, major rivers, major lakes, all projected to be affected by the changing climate. So when we look at cities, we find that they are on the front line in both the cause and the effect of climate change. On the causal side, depending on how you measure greenhouse gas emissions and what you include inside and outside of a city in terms of its, for example, its consumption, 40 to 80% of greenhouse gas emissions come from urban areas. About 2/3 of the global primary energy demand is associated with urban areas, and this is projected to grow in the future. Now, of course, there are many different kinds of cities all over the world, and there's large variation in their energy use. The graph is showing per capita electricity consumption for a selection of cities around the world. So we do see that there is large variation in energy use. It's not completely obvious when you look at the graph and and how cities come out. So some of the colder cities, like Toronto and Denver, of course, in the winter, have high electricity use. But, for example, Los Angeles also does in a much warmer climate on the highly developed city side. Then, of course, development level in terms of Cape Town, for example, lower levels. But then you have cities in the mid-range, Prague, for example, Bangkok, which have middle levels. So, of course, there's variation. But in general, cities are major causes of greenhouse gas emissions, major centers of greenhouse gas emissions. Now, cities, when we look at the impacts and adaptation side, on the vulnerability and impact side, cities are also on the front line on the effects of climate change, because cities and the people who live in them are highly vulnerable to climate extremes, including the projections of more frequent, longer, and more intense heat waves, exacerbated inland flooding, and extended coastal flooding, some of what Jonathan was describing in his talk. So the transformation that is happening now is not only in the research focus on cities, but that the cities themselves are emerging as first responders to the climate change issue and challenge. Now, this is I would say, quite stark contrast to the action at national and international levels, where progress, certainly at the international scale, when I say national, I have to say I'm speaking perhaps from my own perspective of being an American citizen, a US citizen. But certainly when we look internationally, the negotiations are exceeding perhaps at what we used to call a glacial pace. Maybe we can't use that analogy anymore. But the cities, on the other hand, are coming together and are taking the lead in responding to climate change in both mitigation and adaptation. So, for example, the C40 Cities Climate Leadership Group was launched in London in 2005. The World Mayors Council on Climate Change was launched in 2010. More than, by now I think it's 200 mayors and other local authorities have signed voluntary pacts to reduce greenhouse gas emissions. And the graph on the top is showing you the planned cuts in greenhouse gas emissions, percent below the baseline year, for cities around the globe. So you see also that it is not just developed country cities or developing country cities, that cities all over the world are responding on the mitigation side. They are actually having no trouble setting targets and timetables. In the next few slides, I'm going to pose some hypotheses about why that might be so. On the adaptation side, both on the mitigation and on the adaptation side, programs such as the C40, the Clinton Climate Initiative, World Bank has a very strong program on cities with the urban anchor there. ICLE, who many of you are probably familiar with, it's a major NGO which has been working on both mitigation and adaptation for now, actually decades on the mitigation side, and are now embracing adaptation. So the question I now want to pose, and what we've been discussing in the UCCRN, is why cities are taking on the challenge. I'm going to offer a few hypotheses of why. So the first is that cities already are used to intervening to ameliorate multiple environmental stresses. So when you see the list at the bottom, there are stresses in cities. There's already the urban heat island, so cities have excess heat. There's exacerbated runoff. Sound familiar to the climate change impacts? Poor air and water quality, lack of vegetation. So cities have a history of setting goals to respond to environmental stresses, and they also have a very strong record of action, of intervention. White and green roofs, porous pavements, emissions regulations and treatment, for the air quality side, green spaces. So when you make the analogy then when you bring climate change into the mix, you see climate change is really not that different. It exacerbates these risks and issues that the cities are already dealing with. So that's the first hypothesis of why cities are emerging as first responders. The next one is that cities have the experience in responding to climate-related disasters. Because cities have to be the ones, when disasters strike in cities, the city governments are the ones which are there responding on a day-to-day basis after disasters. How do national leaders respond to climate disasters? They helicopter in, say, yes, you're doing a great job, and they helicopter out. Instead, the city leaders are right there on the ground having to deal with climate. This is just thinking about the climate-related disasters. They already have experience. And therefore, the lessons that are listed there about that climate disasters are the product of the interactions between the natural processes and the human interactions, they know that. They know the power of climate disruption on their citizens. They know that preparedness is tremendously important. And then, again, when climate change comes in, increasing those risks, it's not a big stretch to taking on the issue. The next reason why cities, I think, we think are taking on the responder role is that their residents are clearly vulnerable to climate change. In every city in the world, there are differential socioeconomic factors that affect the vulnerability of the citizens within each and every city. So this is just for our New York area. The differentiation in lack of material resources, lifelines, cars and telephones, lack of information and knowledge, language barriers, built environments that are not porous to flooding, and of course, age. Young people, elderly people, many, many elderly people live in cities. And so the cities are also, the vulnerability is right up close. You don't have to be doing some kind of study of trying to figure out who is vulnerable. The vulnerability is right there, right in the city. So all of this brings the UCCRN to conclude that city leaders are at the right level of governance to take action on climate change. They have more direct contact with their constituents. They are involved in day-to-day management. They are practical people, as Carolina is very much right from here from the city of Quito. They're able to form coordination networks with other cities. They are not negotiating over the agenda. I was in Bonn just 2 weeks ago. They spent the entire time, the national negotiators were discussing the agenda of what to talk about. And then they were arguing over who should be chairman of some of the subcommittees. City leaders aren't like that. They don't have time. Now, of course, there are many challenges for urban areas. All cities that we've worked with in every setting around the world have the issue of multiple jurisdictions, multiple stakeholders. They're dealing with multiple issues. There are the trade-offs between current priorities and long-term risks. There's uncertainty in the timing and the scale of the impacts. There's the uncertainty of the financing. Of course, cities for major, perhaps you might call it transformational, some of the transformational adaptations absolutely could not finance these on their own and need both subnational and national government support. There's differential uptake of the issue. It's not that in the New York metropolitan, 21.5 million people in the New York metropolitan region, everyone is on board on climate change. Across cities also, there's differential uptake. And that leads to the one I've highlighted in red, which is differential adaptive capacity across developed and developing country cities, small, medium, and large cities. These are some issues that we as scholars need to really work on together, I think, to really help. And the next slide is about this as well. And then, of course, maintaining momentum across election cycles. If you have a great mayor who is, who's taking it on board, and then he or she loses in the next election, then this can, the action response to climate change can get set back. Just one slide to illustrate. This is from the ARC3 First Assessment Report on Climate Change in Cities, the chapter on cities, disasters, and climate risk, which poses this familiar diagram of the 3 overlapping circles. But what we highlight in the ARC3 chapter is the role of the adaptive capacity. And you see information and resources, institutions and governance, change agents, and this is what we are emphasizing here for cities, and what we as scholars and experts need to help cities of across that whole spectrum of cities to provide knowledge base. What we have found, though, is that there is ample climate risk and response information available for effective action. It is still in limited use if you look at every city across the world, of course, but that there is, we certainly can do we need to do I think, major effort to get the word out and figure out ways that all cities can begin to respond. Okay, now I'm going to turn to how to motivate transformative adaptation. That was on the general transformation to cities taking the lead. This is in a particular city, and these are some examples from New York. This is our flexible adaptation pathway model for response to climate change, with risk going up y-axis, time on the x-axis. The acceptable level of societal risk is the wavy line, and we're trying to be on the wavy green line, actually, which is combination of mitigation and adaptation actions. So where is the New York region right now in this flexible adaptation pathway? So I put an arrow because I think this is where we are. I think the risk was increasing as our urban area was learning about climate change. I think that we have clearly reduced our risks, and when you look at the response to Hurricane Irene last August, there was actual measurable actions reducing risk. So this is where we are. What would lead us to have a jump in risk perception that we were actually much, much closer to that acceptable level of societal risk? And here are some possibilities of what might engender that transformative action in the New York region. So the first one is exactly what Jonathan presented in his talk about sea level rise. Observations of accelerated melting resulting in increases in regional sea level rise, which we already have that, but if it continues and accelerates at the regional level scales as well, and worsening coastal flooding, we will then, in New York, I think, because we have our projections of what those impacts would be. The map was made by Bill Selecki and his crew at Hunter College. Then the transformational response would be perhaps, and it's already under discussion, to go to tidal barriers in New York City, such as London has. Big debate in the New York City panel on climate change. Everyone was duking it out. And of course, the city folks were going, my gosh, talk about mega transformation and mega bucks. So, but that's an example of what would engender that transformation. Now, two other things that might also engender transformational change. The first is the neighborhood vulnerability that I showed earlier. If there really starts to be citizen action on climate change, this, I think, is actually, in many, many places, this is what is needed to actually engender transformational action, probably not only at the city level, but at the national and international levels as well. And the final one is something that, from working with UCCRN and scoping what will be in the second assessment report, the urban designers have come to us and said, we must include urban design in our response to climate change. And here, I think this is in part what is needed for transformation. It's not just the science and the engineering, it's that there is, and this is something that cities can provide leadership on because they are cultural leaders as well as economic leaders. This idea that we need to transform our living environments to be sustainable. So to conclude, my answer to the question posed to me is yes, cities can respond to rapid climate change. I submit that many first responder cities already are, because there are places such as Norfolk, Virginia, which is already having advanced sea level rise and had to already redo their whole waterfront. Later responder cities need help in building adaptive capacity. We need to work on this as a community. And that finally, in the broadest sense, cities are leaders in climate change transformation. Now, I have two announcements. First is, please join, for anyone who works in this area, please join the Urban Climate Change Research Network, and we are right now scoping the second UCCRN assessment report. This is like an IPCC for cities. It's the double helix of nation-state. IPCC really communicates with national leaders. It's really for the nation-states, and ARC3 is for the urban areas and the decision makers there. And then next one is, putting on my Provia hat, is that there's a session this afternoon, no, not this afternoon, right following this, that is going to share the global priorities for adaptation research that the Provia steering group has been working on. And we really want your feedback, so please come along to the Catalina room at the 11 o'clock session. Thank you very much.
Can I ask all the panelists just to come for one question? Unfortunately, we don't have that much time left, but I would like to take advantage of being a chair for asking one question. And while you sit down, I would like to ask you all, from the policymaker perspective, do you think it's possible to find a balance between incremental adaptation and transformative adaptation, especially in the developing world where we also face short-term development pressing needs?
So who are you asking?
All of you.
You guys.
I'll pick that up. I mean, when you actually look at what's happening around the world, is that there already is transformational adaptation happening in the developing world. 2 days ago, the India Times newspaper actually had an article on climate change, and probably about a third of that was actually reporting on transformational adaptations that are happening already. Those are in many cases actually being forced. They're actually under threat. But they also report that when people actually do these sort of changes, they're actually profiting from them. So villages which actually take up some of these practices, those practices are now spreading to other villages. And so people are seeing opportunity arising from that change, from doing things differently. And I don't see there's a fundamental... It's really important not to get hung up on the definitions between incremental and transformational. It's not about definitions. It's actually about structuring our thinking and structuring our activities to bring the best benefit that we can to those people who are making decisions, and doing good, solid research that actually underpins that information that we transfer. So it's not about definitions. It's actually about what we do and how we think about it. And I think we can actually have incremental change which is compatible with longer-term change that doesn't preclude transformational change, but opens up the opportunities that can arise from bigger scale change.
Yeah, if I can, I agree with Mark on that. And in sub-Saharan Africa, for example, we're already seeing, as he's saying, many examples of agricultural systems undergoing what may be quite transformational changes. And I think also to bear in mind that for many households, many communities, we tend to think of sort of people living in households, but actually they're sort of their networks, their kinship networks, their informational networks, the power networks. They extend often over very large areas of landscape in many cases, and so this idea of sort of how do they adapt, how do they sort of shift livelihood options is something in a way that they're already doing, and they're already quite well set up to do this. So I agree. I don't think it's not so much the definitional issues. It's where are the spaces where science and decision support can really help people to make their own decisions to improve food security and livelihoods.
So one perspective I would have from working with decision makers in the Southwest is that a fairly skeptical public here on climate change is that if we can work with them on making decisions with regards to climate variability, and so variability, for example, and drought variability, the things we've focused on, and they actually have success and they see the value of the success in their decision making, then they start to build trust in us as scientists and in the science of climate change, and then they're the ones who start asking questions about, well, what do we do about these bigger changes, about the warming? And so it really, from my own perspective, when I was listening to Mark, I was thinking, you got to do the increment in many parts of the world. You got to do the incremental just to build sort of the relationships with the stakeholder, the decision maker, to produce the will, but also the collaboration necessary to do successful transformative things, the big things, the costly things.
In regard to cities, actually, I think the cities in the developing world are much better placed to do the balance between incremental and transformational. If you compare to, because of the infrastructure investment that is going on to build those cities now, if you look at New York, probably 99% of the infrastructure that we're going to have in 50 years is already there. And it's much, much harder to be transformational on old infrastructure. But developing world cities can be, I think, transformative in a much more facilitated way. So I think we'll be looking, as we already are. New York, by the way, took its some of its new transportation ideas and public space ideas from cities in Latin America, from Curitiba and Bogota. So a lot of really the transformational ideas are actually coming from the developing cities.
Thank you. I completely agree, and I do think that maybe in the next conference we will have more practical and action-oriented presentations too that can complement the scientific ones. Please join me in thanking all these fabulous speakers.